Deep within the vast open-pit coal mine of Cerrejón in northern Colombia, a place where enormous machines carve away the earth day and night, a remarkable discovery was made. In 2009, miners were working through layers of rock that had not seen the light of day for nearly 60 million years. As they dug, they unearthed something extraordinary. It was a fossil, a piece of ancient bone, but it was unlike anything they had seen before. This single piece of bone was immense, far larger than any vertebra from a living animal in the region. The sheer scale of it was baffling, hinting at a creature of truly colossal proportions that once roamed this land. The miners, accustomed to the rhythm of their work, paused to marvel at this strange relic from a forgotten world. The fossil was carefully collected and shown to paleontologists. The initial thoughts were that it must have belonged to a giant crocodile, as the ancient swamps of this area were known to be home to such formidable reptiles. The bone was thick and heavy, and its shape was vaguely familiar. Scientists began the painstaking process of examining it, cleaning away the surrounding rock and comparing it to the skeletons of known animals, both living and extinct. The Cerrejón mine had already yielded fascinating fossils of ancient turtles with shells as large as a small dining table and giant relatives of crocodiles, so another large reptile seemed a logical conclusion. But something about this vertebra was different, subtly unique in its structure. As more fossils began to emerge from the same layer of rock, a picture of an entire ecosystem started to form. The mine was not just a source of coal, it was a window into the deep past, a glimpse into a world that existed shortly after the dinosaurs disappeared. The scientists knew they were onto something special, but the true identity of the creature that left these bones behind remained a mystery. Each new fragment of bone added another piece to the puzzle, and the excitement within the scientific community grew with every find. The size of the vertebrae alone suggested an animal that would have dwarfed anything alive today, a true giant from a lost age of titans. The discovery was like finding a chapter from a book that everyone thought was lost forever. It spoke of a time when life on Earth was recovering from a global catastrophe, and new, incredible forms were evolving to fill the empty spaces left by the dinosaurs. The Colombian mine was revealing the story of the Paleocene epoch, a period of intense heat and lush, sprawling rainforests. The giant bone found by the miners was the first clue, the first word in a story about a creature so immense, so powerful, that it would challenge our very understanding of what is possible in the natural world. It was the beginning of the journey to uncover the truth about Titanoboa. The initial analysis of the giant vertebra led many of the researchers down a familiar path. The swamps of the Paleocene were known to be filled with enormous crocodilians, ancient relatives of today's alligators and crocodiles. These creatures, some of which were giants in their own right, were the expected top predators of that ecosystem. So when a bone of such impressive size was found, the first assumption was that it must have belonged to one of these massive reptiles. The scientific team began comparing the fossil to the vertebrae of extinct crocodiles, searching for a match. It seemed to be the most logical explanation for such a large bone found in this particular geological formation. However, as the scientists looked closer, inconsistencies began to appear. The shape and structure of the vertebra did not perfectly match those of a crocodile. There were subtle but important differences in the way the bone was formed, in the processes and facets that would connect it to the rest of the spine. Dr. Jonathan Bloch, a paleontologist from the University of Florida, and his team were perplexed. They spent countless hours examining the fossil, turning it over and over, comparing it to anatomical charts and skeletons. The bone was telling them a different story, one that was far more surprising and in many ways far more exciting than they could have imagined. The breakthrough came when one of the graduate students on the team, Alex Hastings, noticed a striking resemblance. He was looking at the vertebra and suddenly realized it looked less like a crocodile bone and more like the vertebra of a snake. But this was a difficult idea to accept. If it was a snake, its size would be beyond anything ever recorded in the fossil record or seen in the modern world. The largest living snakes, like the green anaconda, have vertebrae that are dwarfed by this single fossil bone. The idea of a snake this large was almost unbelievable, bordering on the stuff of myths and legends rather than scientific fact. The team decided to consult with a specialist in snake anatomy, Dr. Jason Head from the University of Toronto. When Dr. Head saw the fossil, he confirmed their astonishing suspicion. There was no doubt in his mind. This massive bone belonged to a snake. The moment of realization was a turning point. The puzzle was solved, but the answer opened up a whole new world of questions. The team was no longer looking at a giant crocodile. They were looking at the remains of the largest snake that ever lived. They had discovered a true monster, a creature they would name Titanoboa cerrejonensis, the Titanic boa from Cerrejon. The scale of this animal was simply mind-boggling. With the confirmation that the fossils belonged to a snake, scientists could begin to piece together what this incredible creature looked like. They named it Titanoboa cerrejonensis, a name that perfectly captures its essence, Titanic boa from Cerrejon. This was no ordinary snake. Based on the size of its vertebrae, researchers estimated that Titanoboa could grow to an astonishing length of 13 meters, or about 42 feet. To put that into perspective, that is longer than a city bus. It would have been the undisputed king of snakes, making today's largest species, the green anaconda, and the reticulated python, which rarely exceed 9 meters, look small in comparison. The sheer weight of Titanoboa was just as impressive as its length. Scientists calculated that this giant would have weighed around 1.25 tons, or 1,250 kilograms. That is more than a small car and about 20 times heavier than the heaviest green anacondas found today. At its thickest point, its body would have been about 1 meter wide, easily as wide as a man's waist. Imagine a creature of such immense bulk moving through the water or along the swampy ground. It was a true heavyweight, a constrictor of unimaginable power that would have moved with a slow, deliberate force, its muscular body rippling as it propelled itself through its ancient home. Visually, Titanoboa likely resembled its modern relatives, the boas. It would have had a similar body plan, but everything was scaled up to a monstrous degree. Its head, though proportionally small like that of modern boas, would still have been massive, armed with rows of sharp, backward-curving teeth designed to grip slippery prey. Its skin was likely covered in scales, possibly with a coloration that provided camouflage in the murky waters of its swampy habitat. Browns, greens, and blacks would have allowed it to blend in with the mud, water, and dense vegetation, making it an incredibly effective ambush predator despite its enormous size. When we compare Titanoboa to the snakes we know today, the difference is staggering. The longest snake ever reliably measured is a reticulated python, which was around 10 meters long. Titanoboa was significantly longer and much, much heavier. It represents the absolute upper limit of how large a snake can possibly grow, a product of a unique time in Earth's history. The discovery of Titanoboa completely redefined our understanding of ancient ecosystems and the incredible forms that life can take. It was not just a big snake. It was a super predator that ruled its world for millions of years, a true titan of the past. You might wonder how scientists can determine the size of an animal that has been extinct for nearly 60 million years from just a few bones. The process is a fascinating mix of biology and mathematics. For snakes, the key lies in their vertebrae, the bones that make up the backbone. There is a well-established relationship between the size of a snake's vertebra and its total body length. This relationship holds true across many different species of living snakes. By studying modern snakes, from small garter snakes to giant anacondas, scientists have developed a mathematical formula, a scaling law, that connects these two measurements. When the paleontologists found the Titanoboa vertebrae, they carefully measured their width and height. They then plugged these measurements into the formula derived from modern snakes. The calculation gave them an astonishing result, a body length of around 13 meters. To be certain, they checked their work many times and compared the fossils to a wide range of snake skeletons. The results remained consistent. The massive size of the vertebrae could only mean that the living animal was of a truly gigantic length. This method allows paleontologists to bring ancient creatures back to life, at least on paper, and estimate their size with a remarkable degree of confidence. Estimating the weight of an extinct animal is a bit more complex, but follows a similar logic. Scientists look at the relationship between the length and weight of living snakes. A longer snake is not just longer, it is also much thicker and heavier. Using the estimated length of Titanoboa, and by comparing its likely body shape to that of modern heavy-bodied snakes like anacondas, researchers could calculate its probable body volume. By assuming a density similar to that of a living animal, they arrived at the staggering estimate of over 1,250 kilograms. This colossal weight is supported by the robustness of the vertebrae, which needed to be strong enough to support such a massive, muscular body. This scientific detective work is not just about discovering a monster. It is about understanding the rules of life. The size and shape of an animal's bones tell us a lot about how it lived, how it moved, and the forces it had to withstand. For Titanoboa, the sheer size of its skeleton tells a story of immense power and a very different kind of world. The fact that a snake could even exist at this scale is a testament to the unique environmental conditions of its time. The bones are a direct link to that lost world, allowing us to read the story of Titanoboa and the forces that shaped its evolution. The existence of a creature as enormous as Titanoboa raises a crucial question. Why could it grow so large? The answer lies in the world it inhabited. Titanoboa lived during the Paleocene epoch, a period that began right after the extinction of the dinosaurs about 66 million years ago. This era was characterized by a hothouse climate, with global temperatures that were much higher than they are today. The planet was a warm tropical paradise, especially near the equator where Colombia is located. This intense heat was the secret ingredient that allowed Titanoboa to reach its titanic proportions. Snakes, like all reptiles, are cold-blooded, or more accurately, ectothermic. This means their body temperature is regulated by the temperature of their surroundings. Their metabolism, which is the chemical process that gives them energy and allows them to grow, is directly linked to the ambient temperature. In a warmer environment, a snake's metabolism runs faster. This allows it to eat more, digest food more quickly, and ultimately grow larger. The relationship between a cold-blooded animal's size and the temperature of its environment is so predictable that scientists can actually use the size of an ancient reptile to estimate the temperature of the world it lived in. Using the immense size of Titanoboa as a guide, scientists calculated that the average annual temperature in its equatorial rainforest home must have been between 30 and 34 degrees Celsius, which is about 86 to 93 degrees Fahrenheit. This is significantly warmer than the average temperature of today's tropical rainforests. This constant sweltering heat would have supercharged Titanoboa's metabolism, keeping it active and allowing it to sustain the massive growth needed to reach its full size. In a cooler world, a snake this large simply could not exist. Its body would not have been able to generate enough heat to function properly. So, Titanoboa was not just a freak of nature, it was a product of its environment. The hot, humid, and carbon dioxide-rich atmosphere of the Paleocene created the perfect conditions for life to experiment with size. Giantism was not limited to snakes. The era also saw giant turtles and massive crocodilians. The world was a giant's playground, and Titanoboa was its undisputed king. Its massive body was a living thermometer, a biological indicator of an ancient climate that was hotter than anything modern humans have ever experienced. This connection between climate and evolution is one of the most important lessons the great snake has taught us. The world of Titanoboa was a place of incredible abundance and scale, a sprawling swampy rainforest unlike any on Earth today. The Cerrejón mine, now a dry and dusty landscape, was once submerged beneath a vast, complex network of rivers, lakes, and muddy swamps. Imagine a landscape dominated by water, with towering, broad-leafed trees rising from the murky depths. The air would have been thick with humidity and heavy with the smell of damp earth and decaying vegetation. Sunlight would have struggled to pierce the dense canopy, casting the forest floor and the dark waters in a perpetual twilight. This was the arena where Titanoboa lived and hunted. The plant life in this ancient forest was also gigantic. Fossil leaves discovered alongside Titanoboa's bones show that the trees were huge, with large leaves adapted to the hot, wet climate. The forest would have been a dense jungle of palms, legumes, and other tropical trees, creating a rich and complex habitat. This lush vegetation supported a wide array of life. The water was teeming with fish, including giant lungfish that were a meter long, providing an ample food source for the predators of the swamp. It was a complete and thriving ecosystem, one of the first truly modern rainforests to evolve on our planet. Titanoboa was not the only giant in this lost world. It shared its watery home with other enormous reptiles. Fossils of giant turtles, with shells the size of a kitchen table, have been found in the same rock layers. These turtles, known as carbonomes, were themselves formidable creatures. There were also several species of giant crocodilians, relatives of today's crocodiles and alligators, known as dirosaurids. These creatures were also massive predators, and they would have competed with Titanoboa for food and territory. The swamp was a battlefield of titans, a place where only the largest and strongest could survive and thrive at the top of the food chain. This entire ecosystem was fueled by the hot, wet climate and the high levels of carbon dioxide in the atmosphere, which acted like a fertilizer for the plant life. The sheer productivity of this environment meant there was enough energy to support these colossal animals. The discovery of this complete ancient ecosystem in the Cerrejón mine is incredibly rare. It provides scientists with a detailed snapshot of life in the tropics shortly after the age of dinosaurs ended, showing how life bounced back and gave rise to new and spectacular forms in a world very different from our own. In the murky, superheated waters of the Paleocene swamp, Titanoboa was the undisputed apex predator. Its enormous size and power meant that no other animal could challenge it. Like modern anacondas, Titanoboa was likely a semi-aquatic snake, spending most of its time in the water. The water would have helped support its immense weight, allowing it to move with more grace and speed than it could on land. It was an ambush hunter, using the dark, cloudy water as cover. It would lie perfectly still, submerged just below the surface, with only its eyes and nostrils breaking the water, waiting patiently for unsuspecting prey to come within reach. When a potential meal, such as a large fish, a giant turtle, or one of the formidable crocodilians came close enough, Titanoboa would have struck with incredible speed and force. It wasn't venomous. Like modern boas and anacondas, it was a constrictor. After seizing its prey in its powerful jaws, which were lined with sharp, recurved teeth, it would rapidly wrap its massive muscular coils around the victim. Then, it would begin to squeeze. The constricting power of a snake this size would have been immense, a force of thousands of pounds per square inch. It would not have crushed the bones of its prey, but rather squeezed so tightly that the animal could not breathe and its blood could not circulate. The prey of Titanoboa would have included some of the largest animals in the ecosystem. While giant lungfish were likely a common meal, the evidence suggests that Titanoboa was capable of taking on much larger and more dangerous animals. The discovery of both Titanoboa and giant crocodilian fossils in the same location hints at a predator-prey relationship. It is a terrifying thought. A snake so large and powerful that it regularly hunted and ate crocodiles that were themselves several meters long. The struggle between these two swamp giants would have been a truly epic battle, a clash of titans in a primordial world. After subduing and killing its prey, Titanoboa would have swallowed it whole, headfirst. Its jaws were able to unhinge, allowing it to consume animals that were much wider than its own head. A single large meal, such as a crocodilian or a giant turtle, could have sustained the snake for many months, or perhaps even a full year. Between these massive feasts, Titanoboa would have spent its time resting and digesting, conserving its energy in the warm, sluggish waters of the swamp. Its life was one of patient waiting, punctuated by moments of explosive, deadly violence. the perfect survival strategy for the top predator in its ancient watery kingdom. For millions of years, Titanoboa reigned supreme in its tropical paradise. The hot, stable climate of the Paleocene epoch provided the perfect conditions for this giant to thrive. However, the Earth's climate is never truly stable. It is in a constant state of slow, gradual change. After the intense heat of the Paleocene, the planet began to cool down. This global cooling trend, which occurred over millions of years as the Eocene epoch progressed, marked the beginning of the end for Titanoboa and the world of giants it inhabited. The very factor that had allowed it to grow so large, extreme heat, was slowly disappearing. As global temperatures dropped, the tropical rainforests near the equator began to change. The average annual temperature in Titanoboa's habitat fell below the critical threshold it needed to survive. A cooler environment meant a slower metabolism for a cold-blooded giant. It would have struggled to digest its food, to move with the same speed and power, and to maintain the massive energy requirements of its colossal body. The snake's enormous size, once its greatest advantage, became its fatal weakness. It was simply too big to function effectively in a cooling world. The environmental niche that had created it had vanished. This climate change affected the entire ecosystem. The lush, super productive rainforests began to shrink and change in composition. The food sources that Titanoboa and other giants relied upon may have become scarcer. As the environment changed, smaller, more adaptable animals were better equipped to survive. The era of the Titans was drawing to a close, and a new chapter in Earth's history was beginning. Titanoboa could not adapt to these new conditions. It was a specialist, perfectly evolved for a hothouse world, and when that world disappeared, the great snake disappeared with it, sliding into extinction. The story of Titanoboa's rise and fall serves as a powerful lesson about the intimate connection between life and climate. It shows us that even the most powerful creatures are vulnerable to changes in their environment. The fossils of this magnificent snake are more than just the remains of a prehistoric monster. They are a record of a past climate and a warning about the profound impact that temperature changes can have on the evolution and survival of life on Earth. The giant snake ruled a world of incredible heat, and when the heat faded, so did the Titan, leaving only its giant bones as a testament to its reign.